So, welcome back to Gearhead Geeks, where in this video we're going to continue on getting our KZ400 ready to run. The first thing we have to do is get the electronics sorted out, the electrics sorted out. The turn signals, the turn signal indicator is wired strangely in a KZ400, and when you put on LED signals, it causes problems. So I'll explain that, and I'll explain how we're going to fix it and what we do to fix it. But we'll continue on getting all the wiring done. The tachometer and stuff needs to be wired in. We have no idea. I've been looking on the internet trying to figure out, because I bought this cheap tachometer. I cannot find a wiring diagram. I have a clue. I saw something somebody said somewhere, so I think I know what wires are what. We'll continue on getting the wiring done, because that's the next step in getting this thing to run. We got some exhaust work to do, but we can waylay on that. So the first thing I want to do is we're going to get our turn signal indicator fixed, and I'll show you what I'm going to do. I'll put it on a whiteboard so it's a good explanation. So we'll get to that. So the problem we have with the turn signal indicator on the dash is that if you have a bulb in it, and we have switched over to LEDs, it causes it to act like a four-way. So I'll explain what's going on and how we fix it. So the first thing to do is I'm going to explain how turn signals basically work. So we're going to start with a battery, and we'll go plus and a minus, and we'll ground the minus because that's what it's hooked up. The plus will go to our ignition switch. There's other stuff going on in there, but we have an ignition switch. This is our switched 12 volts. And then this goes up to a flasher. And out of the flasher, and it goes up to our handlebar switch, which has two poles on it. It's called a single throw double pole. And to each of these has a light bulb, which goes to ground. And that'd be the rear turn signal. The front turn signal has a light bulb and goes to ground. Okay, and the same thing over here. Has a light bulb, goes to ground. And the wire comes off of here, whoops, and has a light bulb and goes to ground. Okay. And then what happens in this setup is this wire goes up to here, goes into the indicator light, comes back out of the indicator light, and goes to the other side. As you see, there's no ground here for that bulb. What happens here is when we run the turn signal, is we turn on our ignition switch, and now we are going to turn on the right flasher. So we'll connect the right flasher to the flasher unit. And what happens, you have current coming up through here, through the flasher, and inside the flasher is something called a bimetal strip. And that bimetal strip allows it to, what happens is when it starts drawing current, and incandescent bulbs draw a lot of current. That's why your battery goes dead very, very easily after you leave your lights on. So these draw a lot of current, and that bimetal strip heats up and it moves. And what it does is it disconnects at that point. And then it cools down and it reconnects, and then it heats up and it disconnects, and it does that, and it goes back and forth. And that's how the flasher works. So it just keeps on doing that. Connects, heats up, moves, cools down, reconnects, and works its way back and forth. So anyway, so the flasher is working over here. And then what happens here is the bulbs come on because they've got 12 volts going to them. But the way this works is, the way the indicator works is it has current going through, and it goes through the bulb, and then the bulb takes up some current, and then it tries to run current through this bulb back into this guy and into this guy and off to ground. And there's not enough current to light these guys up because it's going through this bulb. There's too much resistance in the circuit, and these guys don't do it. But there is enough resistance in here, because these are very, very low resistance, to go on ahead and supply the negative side or the ground side to here. So it goes through and it's got a little bit of resistance in it, but this guy lights up. Same thing if we go the other direction. Same drill. What it does is it goes through here. These guys get pure D 12 volts. It goes through this guy, and there's no direct connection to ground. It has to go through these two guys, and these are fairly low resistance, and this guy will light. And it works just perfect. There's nothing wrong with that. But we have changed our system. We no longer have these incandescent bulbs. We have diodes, or light emitting diodes. And we'll draw those in this way. And let me draw another one here. And they have a little arrow coming out of them, letting you know that they're light emitting. Same thing here. And a little arrow coming out. And same thing here. And a little arrow coming out. Okay, so this is our new system. So when we have current going through here, now the flasher has to change, because, as I said before, it draws current and then the bimetal strip heats up in here. Well, LEDs don't take any current. They take just a minuscule amount of current. There isn't enough current being drawn through here to heat up that bimetal strip. And if it can't heat up the bimetal strip, what it does is nothing. It just stays on. So you have to put an electronic flasher in here. And that electronic flasher senses some current, any current going through it, and it will flash. This supplies enough current going through it to get this guy to run, and that's all it takes. So I've replaced the regular flasher with the electronic flasher, but here's the problem. When we have our turn signal on, it goes through here and it lights up these LEDs, and they light up. And then what it does is it ends up going through this bulb, our indicator bulb, and there's plenty enough current going through this now, because this is just fairly low resistance, to turn these guys on also. So whenever you turn it on, you just get a four-way going. That's all that it is. It's just all four of these guys light up. That's no good. So what you have to do, and then we'll go to the other side just to see, goes over here, current goes through here, lights up these guys, goes through our incandescent bulb, which is only a few ohms of resistance, and it'll light these guys up. Plenty. So bad news. That doesn't work. So we have to make a change. And the way we do that, and it's fairly simple, is we come over, I'll get these loose, and what we're going to do is we're going to take a couple of diodes, in here, and we'll hook this guy to here. Then we're going to take another diode, and we will hook it to the other side. And then this guy will go to ground. So what this does is, now what happens is when we hit this switch here, we get current going through here, which lights these guys up. It goes through this diode, and it will turn on this light. But now, instead of it turning on these other guys, the diode will block any current coming through here, and it will not light these guys up. Same thing the other way. We'll hook it up this way, and this will be our left turn signals on. So these guys are getting current through the flasher, and they're flashing. It goes up through the diode, gives the bulb some power, but there's nothing coming back through here because the diode blocks. That's what a diode does. It just allows current to move one way. Voltage, current, however you want to deal with it. But that's what we're going to do. So I'm going to go on ahead and put in two diodes and just rewire that little lamp thing and hook it up, and we'll be done. But that's how the flashers work, and that's how the flashers are going to work. So we'll get that done and see how we do.
So I've gone on ahead and I've installed the 2 diodes that are necessary for our flasher. And I've covered them with the heat shrink and everything is all hooked up. Then I've gone on ahead and hooked up the ground on the other side of the bulb. So now we have our diodes and we have our ground hooked up. So this thing will act like a normal flashing turn signal. So uh, so let's get everything hooked up and plugged in and give it a quick test. We'll get the headlight aimed in the right way where it's not falling down on me. Turn on the key. We're going to flood out the camera a little bit. Hopefully it's not too bad. So let's turn on the turn signal and see if we've got a flashing light. And there we go. And we don't have it as a four-way. Our turn signal's flashing and then go the other direction and it's just fine. So that has been repaired. The diodes work fine and everything is just great.
Okay, so I've gone on ahead and I've rewired our circuit up in here, and now the flashers work properly. I bought a 3D printer. I had never used it, and I needed to build some brackets for our headlight over here. The headlight is, the brackets are just kind of cheap, universal. And so what I need is a spacer that goes around that will go around the fork tube, and we can clamp it down. So anyway, I got out the 3D software, or the CAD software, and I had previously adjusted the printer fairly well. I made sure that the table was correct and all the adjustments were good and all the belts were good. And so I went on ahead and printed my first part, and it came out dynamite. It is just exactly what I want. The finish is very, very nice and smooth. It looks good. Everything came out good. So hopefully I'll go on ahead and get a camera up there. And I only did one, just to experiment to see how everything fit. You know, I said, oh yeah, this needs to be 33 millimeters, and it's ever so slightly small. So I don't know what the deal is with that, but everything is in pretty good shape. And it could be just because it shrunk up from the heat and then back down. So it's hard saying. Inside of here, it's kind of hollow. It webbed up. I was going to make it solid, but I think leaving it hollow is nice, and it'll clamp down on that real well. It worked well, so I can build another one of these, and they will go back in here on this, and it looks like it's going to work fairly well. We'll see. You gotta start somewhere. Okay, so that's done. The neutral light wasn't working, and it had several problems. There was a short in the harness, which I've taken care of, but the neutral switch is dead. It is no longer among us. So I've ordered another one, and in the parts book these are unavailable, but this seems to be the same switch that's in like a bazillion other motorcycles. It's 10 by 125, and it has about 11 threads on it, and the one I got was on Amazon. I saw it, and it looked 10 by 125 and about 11 threads on it, so we'll make it work. If it's a little too short or a little too long, I can make adjustments to it. But yeah, this thing is supposed to spring a little bit in there, and it's just solid, and it just doesn't work. It's dead. So that'll be the neutral light. So but the system is all wired up in here. That's all done. I've got to fiddle around with the tack. I'm going to figure out the wires. We'll go through that. Okay, so the next thing we need to do in our cycle of getting this bike running is we need to adjust the valves. And we put the top end together, but we really didn't do anything with the valves quite yet. I wanted to wait till this video so we can kind of go through all the different steps to get things running. So to get started here, what we want to do is we are going to remove our valve adjustment cover. And that just has one screw on it on this KZ400. Okay, and then there are the actual caps that go into, that cover over where we're going to adjust our valves. And I'd loosened these up previously, so they weren't loose. Okay, so now what we need to do is we need to get the engine in the right position so that we can adjust the valves. So, and I've tried to do this and I can't get the camera to look inside, so you're just going to have to, I'm going to try and do the best I can to explain it. But what we have to do is we look inside and we're going to be seeing where our valves are. So you can, we take in this particular case, a 17mm wrench, and I'm going to turn the engine and it goes backwards, and I'm going to watch the valves as I come around. And I see that the intake valve is coming up, and I see that the exhaust valve hasn't moved. So it looks like we're basically coming up to, our exhaust is closed, our intake is closed, and what we want to do is we want to line up our top dead center mark. And inside here, inside here, let's see if I can get my camera just a little bit better. Inside the point cap, there's a hole, and inside here there's there's marks on the advancer unit, and they say F, and then there'll be a T. F means fire. There's another one further down that's full advance, and it doesn't have any markings on it. It just shows a couple tick marks. Then we have fire, and then we have T, and T is for top dead center. What we have here is our valves on this side are both in the closed position. And you can see when they open and close. It's not that hard to do. So what we need to do now is we need to check the adjustment on these. So what you need to do this is, first of all, you need a feeler gauge. And the feeler gauge will help you, well, it doesn't help you, it tells you the clearance that you have between something. And what you want to do is just drag it in, you have it so you can feel it drag, and it's not, you don't have to push real hard on it, but you don't want it to be super loose. It has to have a certain amount of drag, and that gives you the right thickness, the right adjustment on it, or the right clearance on it. So in this case, the KZ400 is between 0.1 millimeter and 0.15 millimeter. That works out to between 4 and 6 thousandths roughly. So what we're going to do is we're going to go right in between that with 5 thousandths. And so we take a 5 thousandths feeler gauge, which is 1.127 millimeters, so that's right in between. And what we're going to do is we're going to check the clearance on these guys. So to do that, there's a valve spring inside here, there's a rocker, and you need to get the feeler gauge in between the valve spring and the rocker. And in this particular case, it is exactly 5 thousandths. And so we'll go to the other side and check it, and it is, well, it's a little tight. So this is more like 4 thousandths. It's if you can see, it's kind of bending the feeler gauge as I push it back and forth. So it's just slightly off. It's probably within spec, but we're going to make it 5 thousandths. So we put our feeler gauge in, and it's tight. As you see, it's not really moving. It's a little tight. So the way you adjust that is, if you look on in here, there's a couple little marks. There's a plus and a minus, and what that means is if you turn this one counterclockwise, you're going to get more clearance. So we'll take that and we'll loosen this. And we'll take our screwdriver and we're just going to loosen it ever so slightly. And I mean, when I say slightly, I mean slightly. That just moved it just a tiny bit. We go back and we check our clearance. And now it is just perfect. It's just barely dragging. Now, if there was too much clearance, you'll get a noise. When you start it, you'll hear a noise. Too little clearance, and what happens is that as it heats up, the valves don't close all the way, and it starts to burn away the valve, and it really makes a mess out of the engine. So if you have to err on the side of caution, a little bit loose is better. But we are exactly at about 5 thousandths here. It has just got just enough drag to hang on to the feeler gauge, and I'm just going to make sure it's tight. And what I'm doing is I'm applying counterclockwise pressure to the screwdriver as I tighten this up, and it's tight. So this side is adjusted. So what we need to do now is we can go to the other side. But to do that, all that we have to do, because we know that we're at top dead center on our compression stroke over here, to get the top dead center on the compression stroke over there, we need to turn the crank 360 degrees. And that'll bring the piston back up to top dead center, but it will be on the compression stroke over there. So it's relatively simple to do. You just take your wrench and get about where you need to be. Turn it counterclockwise. When I say where you need it to be, just note where it is. And then you bring it back around, and you will see you'll come up on the T mark. There's the F. And we came on the T mark. So now the other side is ready to be adjusted. So we'll take our feeler gauge, our wrench, and our screwdriver. And yeah, that should be enough. Grab this wrench, and we'll go to the other side. All right, so now we're on the other side, pointing at it. So what we need to do here is remove our plugs, or covers. There's one. There's the other. And we'll get our adjustment cover off. And we are ready to check. So now we take our 5 thousandths feeler gauge, and we will go in and push it in. And let me get a flashlight. It makes it a little easier to see what I'm doing. And this one is perfect. 5 thousandths on the money. Okay, let's go to our intake. And this one's a little tight. It's close, and it would be okay, but again, we'll go on ahead and adjust it. So again, to get more clearance, we need to turn this one counterclockwise. And break it loose. And I'm just gonna turn this a little bit along with the nut, see if I can get it to loosen up ever so slightly. And I can feel it, and we just saw the feeler gauge kind of move. And we'll tighten it back up as I hold counterclockwise pressure on the screwdriver, and that's a little loose. That's too loose. It's falling out of there. So what we need to do is the same thing again, except this time I need to let it turn. I'm going to make it turn just a little bit, and I know it's imperceptible, but it did turn, and we're still loose. And you see how this feeler gauge just kind of slipped out. Do this again, and I'm going to give it just some clockwise pressure, and then tighten it up, and let them tighten together, and there we go. That is just perfect. And you have to fiddle around with it a little bit. It is what it is. But now I can go on ahead and make sure this is tight, which it is. And we have the perfect amount of clearance in there. So the valves are adjusted. That's it. It's a very simple operation on the KZ400. You don't have to take apart anything other than a couple plugs, and away you go. So I'll put all this back together, and we will move on to the next thing that we need to do. And one of the things that we need to do in our quest to get this bike started is we have adjusted the valves, so they're in good shape. So we need to double check our timing. We'd already set that up, but we're going to double check it anyway. So what I've done here is I've taken your basic trouble light and hooked a wire to it. We'll hook that to the points, and we have the other side of the trouble light hooked to ground. Turn on our key, and all that we need to do is go in and turn the engine in the direction it needs to go, and then wait for the light to come on. There it comes. We'll go back, and now what we're going to do is we're going to just go till the light just comes on. And if we look inside, we should be lined up perfectly with the F mark, and we are. It is exactly at the F mark. So we know that the timing is good. So now the next stage will be where we go in, and we've got to make sure the carburetors don't leak. We haven't put any gas in them or done anything with them yet, but we now know that the timing is correct. It is exactly timed right, so that helps us a little bit in when we go through everything. So by going through and making sure that the engine is timed correctly, the valves are set correctly, we've already set up the carbs, but we may pull them back apart and look at things. You never know. But for the moment, everything is in good shape. We can put our covers back on. We don't have any issues at this point. I've put the pipes on temporarily. They're there, so at least when we're ready to go, we'll be able to start it. I have no idea how bad they are inside. They could be completely plugged for all I know, but we'll find out. The next thing we're going to do here is we are going to go on ahead and fill the carburetors up with gas, and just to see if they leak at this point. You're not ready to start yet. We're close, but we're not quite ready because there's no oil in the bike. But we do want to see if the carburetors leak. So I've taken this setup here, and this contains gas with a little shut-off valve on it. It's hooked to both carburetors, and my setup has also got the synchronization stuff on this little rollaway. This is just a stand. Well, it's hospital stands that hold those bags. So anyway, with that, what I need to do is just turn on we'll move the camera here to see the carburetors. There are no hoses or anything on these carburetors, so we can see if there's any leaks. We want to check around the bowls and whatever. And if we have to go back in and do something to them, we can. So the gas is on and it is flowing. And this is the first time this thing has seen gas in many a year. Well, so far no major leaks. Good sign. No leaks at all. Everything is dry as a bone. Nothing's coming out anywhere. Nothing's coming out any over the overflows. We've got gas in the bowls, and so far so good. So that test is done. What does leak is my valve here. Now we need to get the neutral light working, and what came in the mail today was our new neutral switch. And this particular neutral switch seems to work in just about half the motorcycles on the planet. So it was easy to get, and we'll see how things go. So I just need to get a socket and put the new one in, plug it in, and we'll go from there. So I've got a 14mm socket, and I need to get the wires out of the way. They're in the way. And there's a little clamp holding it. All right, now, those out of the way, I should be able to get at that neutral switch. We'll take a quick comparison on it to see if they're both the same. When I looked at it, I kind of went by the picture, and I know it's a 10 by 125 thread, but there were 11 threads showing, so I came and I had previously looked at this switch and noticed that there were 11 threads showing. So we should be in good shape. So here we are, and as you can see, they're almost identical. Matter of fact, they are identical as far as the thread depth. So I'll put the little gasket on there, and we'll go from there. This thing is just either rusted up solid inside or something. It just does not move. It is really solid. I'm going to soak it. I'm going to soak that thing in some rust killer and see if it actually comes back to life. But at the moment, what we need to know, we do have a neutral light. And we have a neutral light, which is good. Find the shifter and see if it goes away. Yep, it does. Perfect. So we now have our neutral light working. Everything is good. We can go on ahead and put our cover back on. Okay, now we're going to put some oil in this thing. And one of the things is I'm going to use this Rotella T6. And if you look, there's a little motorcycle right in there. And you look on the back, and it says JASO, MA, and MA2. And that is the motorcycle designation, which means it doesn't have any wear inhibitors in there. So you can use this in motorcycle oil. And so you can get a gallon of this a lot cheaper than regular motorcycle oil. And it works great. So I'll put some oil in this thing. We put oil in this thing. So we had already gone on ahead and we had checked the point gap. And we had set the timing and double checked the timing. And we had already gone through the carburetors and we had gone through, made sure that the carburetors don't leak so far. And then we went on ahead and we adjusted the valves, and the valves are all adjusted now. And so what do we have? We got new spark plugs in here. We checked our coil. We made sure it was okay. We cleaned up everything, cleaned up the wires. I cut off a little bit of the any kind of corrosion off the end of the wires and cleaned everything up there. made sure that everything was okay. Our electric start works. We have spark. So the next thing here is, well, here we go. Let's see if the thing will start. Okay, so I'm going to turn on the fuel. Okay, I'm going to push down on the choke and let the carburetors fill for a few seconds here. So here we go. Here is the big test. I have not started this thing. This thing probably hasn't run in 20 years, but by doing all the things correctly, we should, and I've cranked on it a little bit to make sure things are okay, but there was never any fuel in there. So here we go. Choke is on, gas is on, ignition will be on, ignition is on. So here we go. Ready? No throttle, because these are, when you are using a enricher, you never want to use the throttle. That defeats the enricher. When you're using a choke that actually blocks off the ends, then you can give it a little throttle. That'll give you more fuel. But if you give throttle when you're using an enricher, you're defeating the choke. Here we go. And we'll turn off the engine using the kill. There you have it. A little bit of cranking. What's to be expected after probably 25 years of not running. But everything is nice. It's ready to idle. The engine is quiet. It's nice. It's warming up. There's going to be, I'm going to do some adjustment on the carburetor. We got to get these guys synced up, and we can do that, and I'll go through all of that. But this engine runs, and we are in good shape. Let me turn off the gas here. It is in great shape. We are ready to go. It's now time to start finishing up stuff. We'll get everything adjusted. Like I said, we'll get the carburetors all adjusted, tighten up all the nuts and bolts. We have to work on the exhaust because it's got some ugliness that needs to be dealt with. But, all in all, this thing is working dynamite. We have lights. We have turn signals. Our neutral light is working. Our turn indicator is working. We have a tail light. We have a brake light. We have turn signals built in. Turn signals built into the front. All new chain. The engine has been gone through. Fresh oil in it. Everything is just nice at the moment. There's no apparent leaks that I can see. Again, I'll have to let it sit for a little while. But for the most part, carburetors are in good shape. They were adjusted correctly. We had gone on ahead and set the float levels correctly. We had done everything inside. Everything was clean and nice. And like I say, it took a little bit to start it, which is, pretty much normal. But it was almost nothing. It just needed to get some fuel running through things. We're good. The engine runs, and in the next video, we will go on ahead and sync up the carbs, get all the details done, and get this motorcycle ready to ride. But we're running. So see you next time.